Let's start with a thought experiment. Imagine it's 4:51 a.m., Greenwich Mean Time. All at once, every seismograph on Earth starts to scream, not with the familiar, jagged lines of an earthquake, but with a low, planetary hum that nobody can explain. For 12 solid minutes, the planet vibrates as if a giant tuning fork was struck deep in its core. Out in the middle of the Pacific, thousands of miles from anywhere, the sea itself begins to boil. And then, something impossible happens. A huge section of the abyssal plain, a realm of crushing darkness 7 miles down, begins to rise. In a single, silent, terrifying event, a piece of the planet's crust larger than California is lifted 300 meters the height of a skyscraper. Trillions of tons of rock, pushed up by a force that seems to defy every known law of geology. Overnight, a new, uncharted plateau is born in the depths, and the world's scientists are left completely baffled. There was no earthquake, no volcanic eruption, no asteroid impact. There was only the hum and the impossible thing that came after. In the days that followed, the event was given a name: the Pacific Anomaly. Research ships from a dozen nations converged on the spot, their sonar painting a picture that was just unbelievable. Where their charts showed a flat, featureless plain, there was now a colossal raised platform. Its edges were sheer cliffs, rising 1,000 feet from the surrounding seabed. But here's the most perplexing part: the massive displacement of water. An event that should have kicked off a mega tsunami that could wipe out coastlines across the entire Pacific never happened. The energy needed to lift that much of the Earth's crust is almost incomprehensible, yet it was used with such terrifying precision that the ocean above it was left relatively calm. It was as if the planet had surgically altered itself. Geologists at the USGS and other global institutions ran their models over and over, but every simulation came up empty. No known geological process could explain this. It broke all the rules. An event that should have ended civilization happened with an eerie quiet that was somehow even more frightening. The world woke up to a changed planet, and the scariest part was that nobody knew how or why. The greatest geological mystery in human history had just begun. This event, while a what-if scenario, makes us ask a critical question: what real forces, hiding under the waves, are actually capable of that kind of power? To understand what could make the ground beneath the ocean rewrite its own map, we have to look deep into the Earth's engine room. Let's explore the most extreme geological forces on our planet. And if you want to keep uncovering the world's greatest mysteries, make sure to subscribe and hit that bell. To even start to wrap our heads around a 300-meter uplift, we have to begin with the most powerful force we know: plate tectonics. The Earth's crust isn't one solid shell. It's a jigsaw puzzle of massive plates, all floating on the molten rock of the mantle. Where these plates crash into each other, incredible things happen. At subduction zones, one plate slides under another, building up stress for centuries. When that stress finally lets go, the result is a mega-thrust earthquake. The 2004 Indian Ocean earthquake is a terrifying example. When the seafloor ruptured, it was pushed upwards by as much as 5 meters, 16 feet, displacing a massive amount of water and unleashing a devastating tsunami. 7 years later, the 2011 Tohoku earthquake off the coast of Japan caused an even more dramatic shift. In that event, the seabed shot upwards by as much as 10 meters and lurched sideways by a staggering 50 meters. That sudden vertical jump is what created tsunami waves that topped 40 meters in some areas. And it can get even crazier. In 2016, New Zealand's Kaikoura earthquake was so complicated that it was nicknamed the most complex earthquake ever studied. It didn't rupture just one fault, but at least 21 of them, like a zipper being ripped apart. This caused parts of the seabed to be lifted by up to 8 meters, creating a whole new coastline in just a few minutes. These events are the titans of geology. They can move continents and remake the seafloor. And yet, they're nothing compared to our Pacific anomaly. The biggest uplift ever recorded from an earthquake is around 10 meters, absolute maximum. Our hypothetical event is 30 times larger. A mega-thrust quake powerful enough to do that would be off the charts of anything ever recorded, and the tsunami it would create is almost unimaginable. So, if it wasn't a tectonic slip, we have to look for a force that builds instead of breaks. If tectonic plates can't explain the sheer scale of the uplift, could something be pushing from below? The ocean floor is dotted with hundreds of thousands of volcanoes, and they are the architects of the deep. Instead of releasing energy in a sudden snap, they build new land over time, layer by layer. Sometimes, this happens incredibly fast. The island of Surtsey, off the coast of Iceland, was literally born from the waves in 1963, a brand new piece of land created from scratch in just a few years. Deep in the Pacific, about 300 miles off the coast of Oregon, there's a remarkable natural laboratory, the Axial Seamount. It's one of the most active and well-monitored undersea volcanoes on the planet. For years, scientists have watched it breathe. As magma collects in the chamber beneath it, the volcano's surface slowly swells upward. This inflation is the telltale sign that it's getting ready to erupt. Scientists successfully used this swelling to forecast its eruptions in 1998, 2011, and 2015. Right now, as we head into 2025, Axial Seamount is swelling again. Its surface has risen by about 3 meters, or 10 feet, reaching the same inflation point that preceded its last eruption. Scientists are on high alert, predicting another eruption is likely by the end of 2025. It's a unique chance to see volcanic uplift happen in real time. But even here, the scale is all wrong. The swelling of Axial is measured in meters over years. To get a 300-meter uplift overnight would take an injection of magma so huge and so fast that it would probably fracture the entire crust, triggering a catastrophic eruption far beyond anything we've ever seen. The heat alone would boil the ocean for miles. So, while volcanoes build mountains, they don't seem to fit the clean, massive, and instantaneous uplift of our mystery. So if it's not earthquakes and it's not volcanoes, what's left? The Earth has other, stranger tricks up its sleeve, but they work on completely different schedules. Take glacial isostatic adjustment. This is a process where the Earth's crust slowly bounces back after the crushing weight of ice sheets is gone. Scandinavia is still rising today from the last ice age, but we're talking millimeters per year, not hundreds of meters overnight. Then there are more exotic and catastrophic ideas. Some have theorized about massive blowouts of gas hydrates, which is basically frozen methane trapped in sediment. If that suddenly became unstable, it could cause the seafloor to collapse, not rise. So, could the reverse happen? Could a massive, instantaneous injection of gas or fluid from the mantle somehow push the crust up? This is pure speculation. There's no known geological model that supports anything like that on this scale. We'd have to write a whole new chapter in our understanding of the planet. This is the real heart of the Pacific anomaly's mystery. The event is too big for an earthquake, too fast and clean for a volcano, and too sudden for any other known process. It's an event that combines the scale of plate tectonics with the speed of a gunshot, all while leaving behind almost no collateral damage. It's a geological impossibility that, in our thought experiment, somehow happened. Let's just step back and think about what would happen if an event like this actually occurred. What would a 300-meter uplift of a California-sized chunk of seafloor really do to our planet? The first, most obvious effect would be the displacement of water. We're talking about trillions and trillions of gallons of seawater being instantly heaved upwards. Even without the violent kick of an earthquake, this would have catastrophic effects on global sea levels. But the more subtle, and perhaps more dangerous, impact would be on the world's ocean currents. The deep ocean isn't static. It's a global conveyor belt of cold, dense water that sinks at the poles and flows along the bottom of the world's oceans. This is called the thermohaline circulation, and it drives our entire climate system. A sudden, massive new plateau 1,000 feet high would act as a colossal wall, blocking or redirecting these deep ocean currents. The result would be climate chaos. The Gulf Stream, which brings warm water to northern Europe and regulates weather for half the globe, could be altered or even shut down entirely. Weather patterns would become unrecognizable. Some regions could be plunged into deep freezes, while others suffer from extreme heat and drought. The delicate balance of marine ecosystems, which depend on these currents to spread nutrients, would collapse. It would be a global extinction-level event, triggered not by an asteroid from space, but by a sudden hiccup from the planet itself. The Pacific anomaly isn't just a geological mystery. It's a hypothetical trigger for a planetary system's failure. The puzzle of the Pacific anomaly is that it shouldn't be possible. No known force of nature can account for the evidence. It's an event born from speculative fiction, a thought experiment designed to push the limits of what we know. But it forces us to face a profound truth. We live on the thin, fragile crust of an incredibly powerful and active world. We've mapped the surface of Mars more accurately than our own ocean floor. While a 300-meter overnight uplift stays in the realm of imagination, the real forces we've talked about, the grinding power of tectonic plates and the relentless swelling of magma, are happening right now, under our feet. Real events like the 2011 Tonzohoku earthquake and the impending eruption of axial seamount show us that the seafloor is a place of violent, dramatic change. They remind us that the solid ground we stand on is anything but permanent. The sea keeps its secrets better than anything else on Earth. And while we search for answers, we're left with a humbling sense of awe and a lingering, deep-seated unease about the sleeping giants beneath the waves.